Hi, in this video we will study 6 programming Lisp exercises, and the first exercise that we have here is a redefinition of the function myMember. We discussed in a previous video that myMember is a built-in function and we actually design our own, and the difference with the one that we have here, just to further practice programming, is that in this case when an element is a member of the list, like in this case it returns the value t, which means true. When it's not, returns nil, which means false. In our built-in and definition that we did before, it's very similar. It works the same way. Like I said, it's just an additional practice. Like in this case, when we check for 3 to be a member of the list. When it's not a member, we got nil. But when it is a member, instead of returning true, we were getting a fragment of that list in which we found the 4. Like for example, 4 was found here when we were iterating, and then we return that fragment, the rest from that point on, so which is 4, 6, and 7. Okay, so you go to your notes and you study the other definition. You see that the main difference is now that it's going to return the t in this case. So we got the x in the definition of myMember. So if what we're defining is x, a member of this list, and then here we got 3 possible conditions. The first condition, or like kind of an equivalent of a switch statement, if this list is empty, then the answer is false because it's not on there, right? Otherwise, if that element is equal to the first element of the list, if this is true, then just return true. In our previous definitions, we were just doing the C, D, R, or L, right? That will be the main change. Otherwise, we didn't find it. It wasn't the first member. Maybe it's someplace else. Then this is the T means something else. I mean anything else will be myMember. So we check for the membership of X and the rest of the list, and whatever this returns will be the answer. Okay, so it's very similar to what we did before. So let's see now the other 6 exercises that we will study today. So it says here, write list function for each of the following problems. The problem A, it says given 2 lists returns the intersection. So for that, I have an answer already here that I want to study. So we do the defined definition of the function intersect. So these are my parameters. Again, remember, we're not using any commas, so M and L, and we're not defining any types. So here I had the conditions. First condition is my list, the first list empty. If it is, then the intersection is the empty set, which is nil. So this also means the empty set of the empty list, which also means false. Now we just were using myMember, and then it says is the first element of M a member of L. If it is, then it should be part of the intersection, right? Then we're constructing the intersection, and it says insert that element into whatever is the common elements between the rest of M and L and make a list, and this is the answer. So we're using recursion again. Something else, then we ignore the first element of M, which is car M, and we continue for looking for common elements with the CDR, which is the rest of M, and then from this we construct the intersection, and that's it. That's the definition of the intersect. Now let's see the second question that we want to study. Given 2 lists of the same size, return its dot product. Okay, for that, in case that you don't remember, this is a common function that what the dot product means. We assume that we're getting 2 lists of the same size, because that's the definition of the dot product. It has to be the same size. And I'm not going to check for the size. I'm going to assume that they're given the same size. So in this case, the dot product is the product that is defined between these 2 vectors, and you multiply each element of in the corresponding positions. Like 3 you multiply with 4, 2 with the -1, and 6 with positive 5, and then you do the addition. So this is the way that you solve it. 3 times 4 plus 2 times -1 plus 6 times 5. If we got more elements, then we extend that, right? We had a 4 element, it should multiply with the 4 element, a 5th element with the 5th element, and 6th element with the 6th element, and so on. So in this case, the answer of this is 40. Now, let's see, so this is my question B. Have that here. And the only thing that I did not check for error, that the lists are the same size, we can enclose this in another if statement. Like we can say if size this equals the same size, the length, in this case, length is for the size of the list. If equal length L and parentheses length M, then we can do this, right? Otherwise, we can make a message that they are not the same size. But okay, assuming that we're given lists of the same size, it says here, okay, if this list is empty, so it's 0, because remember we're going to be doing an addition, and then this will be the identity for the addition. We're going to change, so we're going to be iterating with each of the elements, each one of those, and then once we're done, that means we're going to have that empty, we just add the 0, which is doing nothing to the addition. So otherwise, if it's not empty, then we're going to do the iteration of the first element of L with the first element of M. We multiply and we're adding to continue doing the dot product with the rest of the elements. So eventually this will be empty, 0, and then we return a 0, and then we add those there, right? And the 0 will do nothing. So this will be a way that we can solve the dot product. Let's see the question C that we have here to study. It says, given a list returns the same list without any duplicates. So let's say, like in the case of sets, we don't want to have any duplicates. So let's see here, the define function, or the found function, remove duplicates. So we got a list, and then again we got a condition. Is this list empty? If it is, the answer is empty. Now the other part is the first element of the list a member of the rest? If it is, then we found a duplicate because this is coming in the rest of the list. Then we want to remove. So then we ignore core L and we continue removing, because maybe this element is still there, but we continue removing duplicates from the rest of the list. Otherwise, this is not a duplicate, this is the otherwise, then we keep it. We keep that element and we insert it with whatever is the answer of removing the duplicates from the rest of the list. So you see the problems are very similar, and my member function has been very useful. Let's see question D for this set of exercises that we're practicing. So question D, it says, this is a very good question. This function removes all level of parentheses from a given list. So what this means, I think I didn't type an example here, is if we call this function that is flatten, let's see that we got something like this, 3, 2, then here I have 2, 2, and then maybe here I have a 6. So this is my list. So what it says is that we just want to remove all level of parentheses, and so in reality this is a list that contains 1, 2, 3 elements. So what we expect is that we just get the atoms, the elements that are not lists, that are indivisible, in this case 3, 2, another 2, and a 6. So that's what we expect. Okay, so then for this question, which is D, have an answer over here. So the definition of the found flattened, then we get as a parameter a L. Again, for the condition, I'm checking if the list is empty. If it is, then the empty list is the answer. Now Atom checks for an element not to be a list. If I would checking for an element to be a list, I will do list P. When I do this, it will be list predicate is checking for if the element is a list, And similar, adding the p, like for example, if I were checking for this to be an integer, I will do integer p. If I'm checking in generally this is a number, I will do number p. So these are what we call predicates, like null. So that checking if this is an empty, testing for that L to be empty. If it is true, then returns this. In this case, it's checking if the first element is an atom, which means it's not a list, then we want to keep it. And because we want to keep it, it says, okay, then keep it, insert that element, which is not a list, into the rest of the list without any other parentheses, which is what this is doing. Now, otherwise, that's what the T says here. We know that this element, it is a list. In that case, we're going to concatenate the two lists. So first, we need to remove the parentheses from that element because it has parentheses with the removal of the parentheses of the rest of the list, and then we'll append those, and that will be my answer. Okay, for my question E here, it says write a count anywhere list function that counts a given element in an indicated list. So in this case, which is my question E, we have an answer over here. So in this case, for example, I'm counting anywhere for an element in a list. So if I still have these, let's say that I'm counting anywhere for 2s. So 2s may be any place here. So I have a 2 here and a 2 here. Actually, I have 2 2s, right? If I'm counting anywhere for 3s, I have 1 3. So that's what it means. So here, I'm looking to see if how many of these elements are in L, and I don't care where they are in any level in the list. So that's why this will need the help of counts these elements in a list that doesn't have any level of parentheses. So there is no parentheses. So that will make anything easier. So we got this already. So let's use this. And here it says it's empty, the list, then there is nothing to count. It is 0. Otherwise, let's check, is the first element of that list the one that we're looking for? If it is, we found one. Let's add 1 to whatever is the count of those elements in the rest of the list. Otherwise, which is this T, let's ignore the first element and just get us an answer, whatever is the count of those X's in the rest of the list. The last question that we will study in this set of exercises is F, and let's see, we got here we got here, I think we got another one. Okay, so write, I'm sorry, it's G, it's F and G, it's 2 more, it's not, this is not the last one. So write a list function, function Y to compute, no, I'm sorry, write a function to compute the power of X to the Y. So this is what we want to compute. So it's a function, it's not given the name. So write a function, it's not the function Y, write a list function to compute the power of X. So I'm looking for X to the power of Y. So that will be my parameters. So let's look for F. I'm sure I did that already. Okay, so this is F. So I want to compute X to the power of Y. If Y is 0, equals to 0, then anything to the power of 0 will be 1. Otherwise, then we're going to multiply X for X to the power of XY minus 1. And that's it. Very simple. The last exercise, I think we did that before too. I think we did this function before. Write a list function to compute the Fibonacci of a given number in the sequence. I think this was one of the first exercises that we did after we did the factorial of a function. But I had that over here already. So define Fibonacci, and then in this case, if x less than 2, then this is the answer. Otherwise, we add in the last 2 elements of the sequence.